This is a very short, sharp one, and it's a good sort of pattern, good thing for us to recognise what's going on here. So please make sure you're watching Sam 7. Understand we haven't finished this, this is important. Sam, thank you. So this is it here. If we have, this is the general form of quadratic, ax squared plus b equals c, and we say it has roots p and q. So we don't know these values of p and q, but what do roots mean? They mean if you put the number p into this formula, it's going to make it equal to 0. If you put the number q into this formula, it's going to make it equal to 0. They're the x-intercepts on the graph. That's what roots, x-intercepts, we sometimes call them zeros. So if you add the roots together, it's going to equal minus b divided by a. And if you multiply the roots together, it's going to equal c divided by a. So we're going to uncover that pattern with this one example here. Okay, so first let's identify the values of a, b and c. A is 1, b is minus 13, and c is 36. So find the sum of the roots. Well, p plus q, so the sum of the roots, we don't know the roots, but the sum of the roots is equal to minus b divided by a. So that's going to be minus 13, minus b is minus 13, so 2 negatives, divided by 1. And so we've got the sum of the roots. When you add the roots together, you're going to get 13. What about the product? Okay, when you multiply the roots together, whatever they are, we don't know the roots, but it's going to be c divided by a. So that's going to be 36 divided by 1, and we've got 36. Okay. Part B says we've found the sum and product. Let's check by, we're going to find the roots of this quadratic, and then we're going to see that when you add the roots together, you get 13, and when you multiply the roots together, you get 36. So this is pretty evident. So if we're trying to find the roots of this quadratic, that means we're trying to find when it's equal to 0, and so we're going to need to perform the cross product method. So we've got x, and we're looking for two numbers that multiply together to give us 36, and when we add them together, we get minus 13. Alright, so 36 is a good number because it's got lots of multiples, 3 and 12, 4 and 9, 2 and 18. So here we can see, hopefully we're getting pretty good at it. It's going to be minus 4 and minus 9. Alright, minus 4 times minus 9 is positive 36. And minus 4 plus minus 9 is minus 13. So it factorizes to be this. 9 is 0. And so we can see the solutions that make this true are x is 4 or x is 9. Alright? And then we can see these are the roots. That means they're the numbers that make this quadratic equal to 0. And when we add 4 and 9 together, the sum of the roots, 4 plus 9, 13. Oh look, minus b divided by a is also 13, so it's worked in the first case. Okay, we add the roots together, and then when we multiply the roots, 4 times 9, we've got the product of the roots over here as well. And so we can see the sum and product of the roots without knowing what the roots are, okay, just by doing the negative b on a coefficient and c on a. Okay, that's it. So there's only one question I want you to do from that exercise, and I reckon let's have a quick go on it now before recess. Let's get it done, and then we can come back and do D.